Kia ora, Year 12. This is a level 3 calc question that I hadn't done from last year's differentiation paper. It's an excellence question and Jack's asked me to have a look at one particular bit of it, but I thought I'd just get on with it and do the whole thing. So it looks not too bad, but you have to do a little bit of work for this one. So the graph gives us a curve, and the curve has got a pretty simple equation, y equals root 2x minus 4. And it also gives us the tangent to the curve at point P, and the tangent goes through this point here. And we have to find the coordinates of point P. So the key insight in this question, and they've drawn it really well for you so that you kind of can see the key insight, is that at the point P, we've got two things that are the same. We've got the gradient of the straight line that links up P and negative 2, 1, that's the same as the derivative. And that's the big idea that we've been hammering on about since the start of level 2 calculus. But you have to be confident with how you use that in here. So the first thing we're going to do is to figure out the gradient of the straight line, and then we're going to find the derivative, and then we're going to equate them and solve. So that makes it sound really pretty easy. There are a few wee places to go wrong in here. So remember that back in coordinate geometry, we had two ways to find the equation of a straight line. And almost all the time now, I end up back with this one, y equals mx plus c. But the other one that we can use is this, that y minus y1 is equal to m times x minus x1. Now, the messy way to do this question is what I did, which is first of all to go using this one. But we've been given a point here, and so we are better off, I think, to use this one. And if you look at the schedule, what they do comes pretty directly out of this one. So let's just do a little bit of work first on what we can say here about the tangent to the curve. The gradient m. Right, so the gradient of that straight line that P is on. Well, we know that the point negative 2, 1 is on the curve. So that means that y minus 1 is equal to m times x plus 2. And that means that m in that equation of the curve is equal to, what is it, y minus 1 over x plus 2. So that's cool. The other thing that we know is that if we differentiate, we'll get the derivative. And at point P, the value of that derivative is the same as this gradient. Okay, so let's do that differentiation now. So y is equal to 2x minus 4 to the power of 1/2. Giving us dy by dx is equal to 1/2 times 2x minus 4 to the negative 1/2 times 2, which is simply 1 over root 2x minus 4. Okay, so what can I say now? Well, I can put these two things equal to each other and then solve for the value of x, right? So it's only at the point P that we've got this equality, right? Because that's the only place where the derivative will be the same as the gradient of the tangent line. So at P, we can say that 1 over root 2x minus 4 is equal to y minus 1 over x plus 2. Now we know what y is. Y is just root 2x minus 4 minus 1. So you can see that what we're going to get here is a little surd equation. So as I said, this is the smart way to do this question. I'm going to show you my stupid way to do it in a few minutes. So working very slowly, we've got this, so we're cross multiplying this, and then 1 times this, I get x plus 2 is equal to 2x minus 4 minus root 2x minus 4. So it's a nice question because it links up some of the algebra from earlier in the course. So root 2x minus 4 is equal to x, bringing this over, x minus 6. I'm going to square both sides. I get 2x minus 4 is equal to x minus 6 squared, which gives me x squared minus 12x plus 36. 2x minus 4 equals that, so 0 is x squared minus 14x minus 40. Right, but alarm bells should be going off at this point because we got a surd equation up here, and so now we've got a quadratic. We're going to get two values of x here, and we're going to have to check them really carefully. So 0 is equal to what? Well, it factorizes nicely, so that's a good sign. Minus 10 and minus 4. That tells me that x is equal to 10 or x is equal to 4. Now, when x is 10, y should be root 2x minus 4, which is the square root of 16. So y is equal to 4. And when x is equal to 4, y is equal to the square root of 2 4s are 8. So y is equal to 2. So nothing wrong here. That all looks fine. So the point is either 4,2 or 10,4. But what we've got to check is that we didn't get an extra solution coming in, because we often will when we've got a surd equation, right? And you can see from looking, there's only one of them is right. So we've got to have a justification for which one it is. So now we're going to check this equation. Is the y value actually equal to the right thing? So at, what's my first point? 10 something, hang on, 10 and 4, we get this, the square root of 16 on the left-hand side. Right, so root 16 is the left-hand side, which is equal to 10 minus 6. Yeah, so it works. Okay, so it's valid. And then the next one is if we check out what happens at 4,2, we get, what do I get? Root 4, what was it? 4 times 2 minus 4 is equal to 2, which is my left-hand side. But on the right-hand side, I get 4 minus 6 is equal to negative 2, which is not equal to the left-hand side. So it's not valid. So there you go. So the point that we're after is this one here, which is 10,4. So 10,4 is the only solution. So the other way that you can do this, and I don't think I've got the energy to go all the way through what I did with it, because it just feels really dumb now that I've seen the smart way, is that you can get there if you use y equals mx plus c. So I'll start you off on the way that I did this. And I said that at this point here, we're going to call that x coordinate xp. Right, so the equation will be y is equal to 1 over 2 times xp minus 4, x plus c. So we know that that's the equation of the curve. The next thing that I can do is I can substitute a negative 2, 1 being on that curve. And that's going to give me, especially if I get rid of some of this stuff from before, that's going to give me a second equation. So we'll get 1 is equal to negative 2 over this. Is that what I did? That's not what I did. No, that's not what I did. Hang on a sec. Guys, I think I'm actually going to leave it here. I don't want to do another 10 minutes on this, but basically you will get there if you use this method. But you're going to have to be really careful, because you've got to distinguish between your xp and your x, which is your variable in your line, right? So this is the specific value that we don't know, and where you get down to is you get this for your tangent equation. And then for your constant, you get this, right? And you will get there. You just have to do a little bit more work than we did when we did it the first way. Anyway, thanks for watching. Anyone who's watching until this point, I'm sorry for flaking on you and not doing the second messy way. If you really want to see the working for it, send me an email.